Welcome to e-Pathasala lecture series. We are discussing about cryptography and network security, and today's topic we are going to discuss about stream cipher and block cipher. To understand the learning objectives are to understand the stream cipher, to understand the need for stream cipher, and also we are going to discuss about block cipher. In addition to that, we are going to discuss about advantages and disadvantages of stream and the block cipher. Keywords are stream cipher, block cipher. So, actually why we are going to discuss about this particular topic is, in modern cryptography basically the encryption and the decryption process may be categorized majorly into stream cipher and the block cipher. The cipher means the text which is unreadable by the human, and how we are going to deal that particular cipher. If I am going to consider zeros and ones, how I am going to perform the encryption, whether I am going to consider a series of zeros and ones or I am going to take a block of zeros and ones during the encryption process. So, this is the basis for any cryptographic algorithm, how they are going to deal the data to be encrypted. So, first we are going to discuss here is stream cipher, how I am going to make the stream cipher, and also what are the disadvantages and advantages of your stream cipher. In stream cipher, where we can say generalize of one time paired, that is where it is using each and every plain text going to be using the corresponding key stream with the help of your one time paired. Stream cipher is initialized with short key. So, when I want to generate the stream of bits, first I need to initialize with the short key. Then after that the key is stretched into a longer key stream. So, the basic idea here is I will take a key as an initial input, and later on I started to stretch the key, that means expanding the key according to the size of the plain text. And it should have a pseudo random property. The pseudo random property will ensure that repetition, that is where I am going to have randomness in the output of my encryption process, and key stream is used like a one time paired as only once during the encryption of the process. And the basic operation in the stream cipher is XOR to perform encryption or decryption of the particular text. So, when I take a key, I simply will go for XOR operation in order to generate the encrypted cipher text, or XOR operation for the decrypted plain text. So, how I am going to define the stream cipher, how I am going to represent, in what way I can able to understand how this process is going to be happening in the cryptographic algorithm. Let E be an encipherment algorithm. Suppose I am going to take a algorithm, any algorithm which is represented as E. Let E suffix k of B be the encipherment of message B with key. So, it is represented as I am taking B as a plain text and E as the initial key, and my algorithm is E, where it is going to be encrypting the plain text. Now, let us take that M is equal to B1, B2, B3, B4, like that it go up to N, where each B of I is fixed length. That means I am going to consider B as the fixed length and K as K1, K2, K3, like that Kn, it is going to be keep on going. Now, I can generate ciphertext using the stream cipher, that where it is going to be considered as E k of M is equal to E K1 of B1, K2 of B2, K3 of B3, like that it will be generating the stream cipher. So, as we can able to understand here, when I am taking a particular message, if I am taking a message with B1, B2, where each B is a fixed length and their corresponding key is going to be generated based on the initial key vector. So, now I think we can able to understand how the key stream cipher is going to be generated. So, this is the formal definition of stream cipher. We look at the diagrammatic representation. Now, we see the structure of stream cipher. So, as we have defined how the stream cipher is generated with the help of your initial key and the message, now we look into the internal structure of your stream cipher. So, in this structure, where we can able to understand there are two blocks, one block is encryption, another block is decryption. So, as we are looking into the encryption component, where you can able to see there are two different inputs, one is your key, another one is message stream, that is your plain text. So, if a user want to send a message, it need to be generated as a cipher text with the help of your key, what is going to be given during the encryption process. The idea here is, as we mentioned during the definition, where your initial key k is going to be given in the block where it is a pseudo random byte generator. So, which will be helping to generate that k1, k2, k3 etc., and this k1, k2, k3 are going to be XORed with the M1, M2, M3, that message B1, B2, B3. So, with the help of this XOR operation, it is going to be generated as the cipher text. So, now we can able to see that after this encryption process, we come out with the cipher text byte stream. So, the idea here is, when I am taking a byte stream of message, each message is going to be XORed with the newly generated, that is your stretched key, it is going to be generating your cipher byte stream C. And during the receiver end, that is after the stream text byte stream has been received in the receiver side, where it is going to be performing an decryption operation. So, in this decryption operation, again both has to use the same key. For example, here I am using k, means the same k must be shared with this person also. Now, I have a k, and again I need to go through this process as same as that of your encryption, where it is using the pseudo random byte generator, the same process, and all this cipher block, that is your cipher bytes, are going to be XORed with your ki, k1, k2, k3 like that, and it able to get back the original plain text. So, I think now we have understood the stream cipher structure, how a message byte stream is taken and how it is going to be encrypted, and same way on the other end how it is going to be decrypted with the help of your pseudo random generator. The stream cipher structure in this, what is the idea of randomness? Okay, why we need to go for a pseudo random byte generator? Here, the randomness of stream key completely destroy the statistical property in the message. What is this statistical property in the message? As we already known in the case of our classical cryptography, in the case of a repeated pattern, for example, if I am saying that letter E is going to be repeated more frequently than that of other letters in the English alphabets, where the attacker is keen to know about what is that, how it is mapped. So, that statistical property is completely destroyed with the help of your randomness. And also must never reuse the stream, that means the stream key, once it is used like our OTP, here you must never reuse your stream key, because it leads to your historical attack. So, history attack may happen during your reusing of the same key, otherwise can recover the message. If these properties are not going to be there, then automatically any attacker easily can get your message. So, the properties of stream cipher. So, what are the things we need to consider? For example, I am going to design a stream cipher algorithm. So, I must consider these properties for designing the algorithm. First thing is long period with no repetition. That means, when I am sending the stream of bytes, it will not give any clue to the attacker or any particular third party who is going to be watching on your data for a longer period. That means, should have some duration between the repeating pattern. It is not going to be frequently occurring of your repeating pattern in the byte stream. And statistically random, that means it will be where I can able to destroy the statistical property. That means randomly, statistically it must be random, so that there should not be any repeating, and depends on large enough key. That is, how much is the size of your message, definitely that much your size of your key, and large linear complexity. So, where I am going to for large linear complexity, definitely it makes this cipher is under the attack, to be free from the attack. So, properly designed can be as secure as block cipher with the same key. So, what I have to do is I need to consider this property for designing an algorithm. Once I designing, I can able to ensure that their secrecy is similar to that of your block cipher with the same key size. So, benefit of this stream cipher is usually simpler and faster, because as we consider some of the block cipher, it takes much time and also more complicated, but in this case of your stream cipher, where you can able to see just a stream of ones and zeros XORed with your key bytes. So, this is the stream cipher model where the output function appears random. So, here this diagram is explaining about how you are going to generate the cipher text from the plain text. M of Mi is converted into Ci with the help of your Ki. So, here we can able to see that there is Si, that is your Si block, and there is an F block. In addition to that, we have one G block. These three blocks plays important role in providing the Ki, that is your key stream. What is this Si? So, Si is the state of cipher at the time t is equal to I, that is state of cipher. Cipher means what is you are getting as the output, cipher, and F means state function. The state function will determine what is the next state of your state going to be used for generating the output function. So, this is G is your output function. So, initial state, output, and state functions are controlled by the secret key. So, what I am choosing at the initial step of encryption, what we can say that is a secret key. So, these states are controlled by what is the key we are using for initially during the encryption process. So, what are the advantage of the stream cipher or stream encryption? So, we have some of the advantages as well as disadvantages if you are going to choose your stream cipher algorithm for encryption or decryption. Now, let us see that what are the advantages here is the speed of transformation. That means already we mentioned it is simpler and fast when compared to our block cipher. When you are comparing the stream cipher, it is simple and fast. Speed of transformation. Algorithms are linear in time and constant in space. So, algorithms are linear with respect to the time and also they are constant in space, and low error propagation. So, as in the case of block cipher, there will be more errors. We already know about that one error will be propagated to the next block, and frequently the blocks are going to be corrupted. In this case, an error in one encryption symbol likely will not affect the subsequent symbols. So, low error propagation. These two are considered as advantages of your stream cipher, and in the case of your disadvantages, it has low diffusion. So, we will see what is this diffusion and confusion which is occurring in your modern cryptography. Basically, low diffusion, all the information of your plain text symbol is contained in a single ciphertext symbol. So, low diffusion. Diffusion means that is sometime there is a chances of the information of your plain text is contained in the ciphertext symbol. Actually, what is the diffusion property is to hide the information of plain text in the ciphertext. But now we can able to see that in the stream cipher there is chances where you can able to see the plain text contained in the ciphertext. So, where the attacker can get control over that and they can able to identify what is the plain text from the ciphertext without knowing the key. The next disadvantage here is susceptibility to insertion and modification. Susceptibility to insertion and modification, that means tampering of your input. During the transmission of the data there may be tamper in the message. So, an active interceptor, that is an attacker who break the algorithm, might insert spurious text look like authentic. So, some random input or some attacker they want to break the algorithm, they can use some interesting or some spurious text which look like authentic. So, easily they can able to break into your system. So, these are some of the advantages and disadvantages of your stream encryption. The next what we are going to discuss here is block cipher. Earlier we know that in the stream cipher we consider message byte stream as well as the key byte stream. So, both are simultaneously generates their cipher byte stream. But in the case of your block cipher, the block cipher breaks the message into fixed length block and encrypt each block using the same key. So, what we have come out with the difference or the contrast between your stream cipher and block cipher is, in the stream cipher I will take the key, similarly in block cipher also I take the key, but there I will take the stream of bytes to encrypt into ciphertext, but here I will take fixed length block. I am not going to consider a stream, I am going to take as a fixed length block. So, these kind of algorithms, they take a block of input and they started to encrypt each block using the same key. So, one of the very known and also popular symmetric key cryptographic algorithm is DES, data encryption standard. This is an example for block cipher where the block of 64 bits are encrypted using 56 bit key. So, they are going to use the 64 block bits, that means the plain text is going to be divided into each block of 64 bit in size and it is going to be encrypted using 56 bit key. Actually the size of the key is also 64 bit. How we are going to define or how we are going to represent the process involved in your block cipher as similar to that of your stream cipher. I think the formal definition of stream cipher we already discussed. Now we can consider with respect to block cipher how it is get modified. So, let E be then encipherment algorithm and let EK be as similar to that of your stream cipher where B is your message with the K as the key. Here we are going to consider M is equal to B1, B2, B3 like that up to the size of your message with each B suffix I is of fixed length. So, the block cipher is a cipher for which E K M is equal to E block, that is it is mentioned just to represent the differentiate, just taking the B1, B2, but one difference we can able to see from the earlier stream cipher is there will be we have one K1, K2, K3 as a key stream, but in this case there is no key stream. All the blocks, let us take B1, B2, B3, all the blocks are going to be encrypted with the same key of mentioned during the initial encryption process. So, now I think we understood that a formal definition between your stream cipher and block cipher, where in the block cipher each block is going to be encrypted with the same key. That means there is no stretching of your key for each block as like your stream cipher. So, block cipher principle where the blocks cipher look like extremely large substitution. So, where we have a substitution and permutation, we will take very large block of data and it is get substituted at each and every process and it is going to be converted into a ciphertext. So, we should have we should need a table of 2 power 64 entries for 64 bit block, and also in an arbitrary reversible substitution cipher for large block practice is not practical, size is not practical. So, 64 bit generally substitution block cipher key size is 2 power 64 combination. So, most symmetric block ciphers are based on Feastel cipher structure. So, they will taking the block and they will be dividing that 2 half and do 1 half with the process, the other half is going to be generated. So, Feastel structure is going to be adopted by most of the symmetrical block cipher algorithm, how they are going to be converted with respect to our plain text into a ciphertext. And also needed, since must be able to decrypt the ciphertext to recover the message efficiently. So, again this Feastel structure is must be able to decrypt the, again the reverse process, once we are able to encrypt it, it should be able to decrypt it in order to get the plain text. So, some of the real world block cipher algorithms are most popularly known DES and AES, and then we have some of your RC2 and RC4, these where it is coming under your stream cipher algorithm in the case of our stream cipher and block cipher encryption. So, here in the block cipher where they use two different boxes, one is S box, another one is P box, that is substitution permutation cipher. In 1949, Shannon introduced an idea of substitution permutation network, SP network, modern substitution transposition product cipher, which is a key component of your encryption algorithm. These forms the basis for modern block cipher. These SP networks are based on two primitive cryptographical operations, that is substitution and permutation. So, we normally the permutation, the transposition we represent with the permutation. So, there will be a S box and a P box. Each and every time when I take a block of information, this block is going to be converted into ciphertext with a series of your S box and P box combination in order to provide confusion and diffusion of the message. So, I want to provide confusion and diffusion of the message. So, how I am going to ensure that confusion and diffusion with respect to your substitution and permutation. So, confusion, diffusion, what do you mean by confusion and diffusion? It is actually introduced by Shannon to toward the crypt analysis based on statistical analysis. Okay, let us assume an attacker has some knowledge on the statistical characteristics of plain text. Suppose I am taking the crypt analysis, an attacker has a knowledge about the statistical characteristics of plain text, then easily he can able to break into your system if there is no, or if your algorithm is not having the property of your confusion and diffusion. Cipher needs to be completely obscure statistical property of your original message. That means, as also we have looked into the stream cipher, when I look into the cipher text, definitely I should not get any idea about my plain text. Actually, we have seen that in the case of your disadvantage of your stream cipher. So, in the disadvantage of your stream cipher, where we have seen that low diffusion. So, as the case here, we can able to see that the stream cipher need to be completely obscure the statistical property of your original message. That means, when the attacker capture all your cipher text, he should not get any idea about their original message. So, it is also mentioned in the case of your one time pad, where it is addressing this property. So, what do you mean by diffusion? What do you mean by confusion? Because we state that this is the important property to make your algorithm to protect from the attacker. So, diffusion means dissipates the statistical structure of plain text over the bulk of cipher text. When I am taking the cipher text, I should not get any information related to your plain text, then we say the plain text is completely diffused into cipher text. What do you mean by confusion here is, it makes a relationship between ciphertext and the key as the complex as possible. So, here confusion makes the relationship between ciphertext and the key as complex as possible. So, these two are very important for designing of any encryption algorithm. One is hiding the information are related to the encryption process with respect to your ciphertext. Other is hiding the key. Even attacker knows about the ciphertext, it is very, very difficult to get back the key because it is creating a confusion during your design of an algorithm. So, there are some advantages and disadvantages related with your block cipher also, that is during the encryption process. High diffusion, where one of the disadvantage of your stream cipher is low diffusion, and immunity to tamper. So, all the disadvantages are overcome with the help of your advantage of your block cipher. Whatever the stream cipher disadvantage has been overcome with the help of your block cipher. High immunity to tampering of your message, and disadvantages are slowness of encryption. When compared to a stream cipher, it is very slow. It will take more time for creating the ciphertext from the plain text, and error propagation as mentioned in the advantage of your stream cipher, error is propagated to entire block, that is another disadvantage of your block cipher. So, overall we come out with a conclusion that what is the need for stream cipher and block cipher, and also we also understand the working of your stream cipher and block cipher. Moreover, we need to know when we need to go for stream cipher, when we need to go for block cipher with the help of your advantages and disadvantages. Thank you.